So hi everyone. Yeah, so I will share my slides. Quoi? Ouais, non mais okay.
I'm very sorry, but I'm sorry. Before we start the presentation, I think that we didn't have today the part where we share the questions or the updates. But I just wanted to add one thing. I just sent all of you the message on the general channel about the Green conference in Paris. So if you would like to help us in the booth and the Represent Association, let us know. It would be really great to have Boavizta members present at the Green conference. And I think that we have Gael who is present. I don't know, Gael, maybe if you would like to say a few words about the conference this year.
Well, I think you presented it perfectly. Maybe the only interesting part that could be mentioned is that this year we make an extra effort to gather people from all over Europe. So it will be more a European conference than a strictly speaking French conference with speakers from, I think, 4 or 5 different European countries. As usual, it will be exclusively in English. And it's over 3 days now, with the first day of workshop, a second day with a lot of use cases and also a very specific NGO track where obviously Boavizta will be deeply engaged, because this is I took a crazy bet to gather whoever would like to collaborate at the European level between NGO, mostly in the green IT field, and honestly, pretty much everyone said yes. So I think we have already more than 15 NGO, and they will have a room and they will do pretty much whatever they want to do. And and the last day is really about in-depth talks. Got a bunch of academics, very studies, etc., etc. But yeah, I think that's good enough. Yeah, if you want more information, you can reach out to Michelina or to me. I'm more than happy to answer. Thank you.
Thank you, Gael. So again, the conference is really amazing place to hear all the updates, everything that is happening, and like Gael was saying, we're on the European level, so we are a little bit leaving this French ecosystem too. And the conference is great, people are great, the food is great. So let us know if you would like to represent Boavizta at the booth. Thank you.
Do you see my slides now? Okay, great. So yeah, hi everyone. For those who don't know me, I'm Benoit Petit. I'm one of Laurent's colleagues, and I'm in Boavizta for a few years now. And today what I wanted to do is to propose you a collaborative workshop on data centers. I will explain why and where this idea came from. So the origin of this idea came from basically a study that with Eric Forboul, who is also, I think, who is in the room, we participated to for ADEM, which is a study that tries to draw a projection of data centers consumptions regarding energy, water, and land use in France from today up to year 2060. So this study is almost finished. It will be released in a few weeks. At least there is an executive summary that will be released in a few weeks on ADEM's website. Then there will be the full report that will be released hopefully by the end of 2025. And I will explain a bit more in detail after this part of the study, but basically the idea is that we first collected the French data centers in a database, collected many data regarding those data centers. And the second part of the study was a prospective projection model that was able to ingest data from 2024 and propose projections up to 2060. So today I will be really focused on the 2024 part, or 2025 now, which means what I propose to you is to see how it goes if we try to be, all of us, investigators, and sharing our work and working together on building a data set regarding data centers. I will explain during the presentation how. So it's really an experiment because so far I've done it twice, but only in real presence, not online. So online would be another kind of exercise, but that will be interesting to see how it goes. And before that, I will just give you a very, very short presentation, like not more than 10 minutes, I guess, to give you a bit of context so that you understand the idea, give you some first results from the study so that you see how it has been applied and what results it produced so far for France. The idea being that in this workshop, we could go further than that. The idea would be we could collect data from European data centers, worldwide data centers, whatever, the one you want, actually. That's the idea. So the subtitle of the presentation is Towards a Citizen-Led Global Digital Common, because the idea behind it is, as everything we do in Boavizta, but what I would like is that it's an initiative that's joined by more associations than just Boavizta included. There are discussions with Data for Good, there are discussions with the Shift project on how we could build a global digital common regarding data centers. So we are trying to put the building blocks today. So with the growing wave of Gen AI, what I want to show you is why it's becoming more and more important to have a better understanding on data centers and the underlying infrastructures of our services, but from a physical point of view. It was already a real issue because the global knowledge regarding data centers is very poor. You will find databases online, you will find informations, but they lack a lot of data. There is a lot of lacks in it. And with Gen AI, it's becoming more and more important to do this kind of mapping and data gathering work, I guess, because there are many changing factors that give very different dynamics since Gen AI is influencing data centers. So I'll try to explain why, so you have a bit of context of what we try to collect in terms of data. So first, so that you get the difference between, let's say, a typical data centers and a Gen AI oriented data center, we'll start from the rack. So the rack, really in French, so l'armoire informatique. So really the rack in which we will store the servers on top of each other. And the rack is an interesting unit because it's a unit where you can get data regarding the power, the electrical power installed, regarding the square feet or the square meters occupied on the floor. And those are building block data that you can use so you better understand what it means regarding the data center. And so that you get the difference between typical racks in typical data centers or GenAI oriented racks in data centers, we will start from a reference, first key point reference, which is what electrical power you can ask in a typical French household. So I took the French data, but that could be from any other country. Actually, it would be just a bit different, but not that much. So here on this graph, so sorry, I didn't translate the graph, but I will explain it. So you have two values. The first values is 3.6 kilowatts. The second one is 7.2 kilowatts. And so the second one, the dark blue one, is the maximum power a French household can ask for. If, let's say, you have a typical contract with the energy provider, you don't have any specialized contracts paying more money to have more power. You have just the average one. So it's about that, 7.2 kilowatts. And 3.6 would be if we imagine that your average power, the average power you asked for is half of the maximum capacity, which is a lot, actually. Most of the time it's lower than that, but let's imagine you have many devices connected in the same time to the network. That would be our reference key point. And starting from that, we'll first compare it to the average electrical power we find in a typical rack in a data center. So if we took the data from the Uptime Institute, which is a well-known institute that does a lot of surveys and studies worldwide regarding data centers. So it gives us three data points. So the first one would be the average power installed per rack in the world in 2011. So it's 2.4 kilowatt. In 2017, it became 5.6. So it doubled, basically. And in 2020, it became 8.4. So in 2020, the average typical power installed for a rack was higher than the maximum capacity you can ask in an household. So now if we look at the racks specialized for GenAI, looking at NVIDIA products. So the first product I will choose, so I won't show the full portfolio of NVIDIA, but some examples that are very typical of modern GenAI data centers. So if I take NVIDIA NVL72, which is a rack fully equipped for GenAI with already servers installed, with network installed, with storage installed. You just have to plug the rack, basically. That's the idea. So this rack, fully equipped, asks for 120 kilowatts of power. So that would be 16 times the maximum capacity a French household can ask for, and 33 times its average, the average power he asked for. If we take much more recent product from NVIDIA, so the NVL 576, because the 72 is already several years old. It's not the more recent one, and the 576 is really the one that are sold now. So this rack asks for 600 kilowatts. And starting from our reference key points, it would be 83 times the maximum capacity of a French household and 166 times it's the average power in the French as well. So you starting from that, you imagine that it has many implications on everything that's in the data center. If you have a data center full of that kind of racks, that kind of equipment, hardware, it's not the same starting with cooling and how you cool all the heat emitted. It's not the same. With a typical rack, even pretty power intensive racks up to 40 kilowatts, you can cool the servers with air. That works. It's done almost everywhere. You just have a cooling unit. So it's not visible here. It would be in another room in the data center, but there is a cooling room where you have equipments that are made to produce cool air. So that cool air would be pushed in the IT room, as you see in the drawing. The servers would suck up this cool air, then it would go out as hot air, and this hot air would be then expelled outside of the IT room. That works up to 40 kilowatt rack. Now with Gen AI, we see intensities above 40 kilowatt. It could be for the lowest could be 70 kilowatt per rack, or 120 or 600 as we saw earlier. And then you need to have direct liquid cooling. So basically it means we have pipes that go up to inside the machines that will bring either water or a mix with water and glycol or other kind of liquids, will bring that mix of liquids up to the chip itself. So really in contact with the chip, so that a maximum of heat possible is removed from the chip and sent elsewhere. So that's what you will find in Gen AI based infrastructure. And what you can imagine is that it doesn't have just implications regarding the cooling gear, but it has an implication on the building itself. So an example that we found interesting during the study we ran is an example from Meta. So Meta had to demolish a complete building. So there is a mistake on the slide. Sorry, a complete building in construction phase to apply a new design that works for Gen AI. So in 2022 November, you see that there was the first building being constructed. In 2023, the building was up and probably running because it was pretty advanced. Then in May 2023, it disappeared. And in 2024, a new building appeared with a totally new design. So this case was explained by Semi-Analysis, which is a very good media and consulting company working on data centers and Gen AI. What we see is that this new design, those new design constraints have a direct impact on building. So I didn't get in those slides the big trends on construction. That was Eric's part last time we did a similar presentation. But it's huge. It's really huge. Just to mention, at Microsoft, I think it was plus 21% of greenhouse gas emissions from 2023 to 2024, if I'm not mistaken, mostly because of the new buildings. At Google, it has been plus 50% in 5 years regarding greenhouse gas emissions. And a big part of it was the buildings as well. And so just to just funny thing, when we prepared the presentation for the last time we did it, we wanted to have a look to this meta data center because we saw in 2024 it appeared with a totally new design. And if we look today, so do you see my screen with the map? Is this okay? I hope so. If we look now at the place where the data center should be, it disappeared again. So it was pretty much here. And we see that the building has been destructed once again. So we don't know exactly what's happening, but it's probably because of other new constraints and needs regarding embracing the GenAI wave. And it was it was pretty shocking when we saw it preparing presentation. So if I will just have a look at the chat because I have no. Oh, okay, there are some questions I will answer later, just to be sure that you see my screen and there is no technical issue. And now another example I want to show you is the effect that GenAI and new data centers GenAI designs have regarding electricity production. Because today, most of the data centers are connected to the local national electricity grid, consuming the same electricity as you and I consume. Sometimes they buy guarantee of origin certificates to be able to say that they consume green electricity from alternative providers while they consume the same electricity as you and I do. Sometimes they actually consume renewable electricity coming from renewable because they have local production. It might happen. But so far it has been a pretty homogeneous ecosystem regarding electricity production. Today with GenAI data centers, we have pretty big differences. So the first example I want to show you is Colossus One from XAI. So XAI, I think you might recognize it. It's the data center for X, the social media from Elon Musk. If I have enough bandwidth to charge it. What's happening? Okay. They have a big demo effect. I just have a try with another browser quickly. Oh yeah, okay. So sorry, I will just switch my screen. To the full screen so I can show you. So XAI data center is this one. So what's really interesting here, first, the size is pretty huge. It's like in Marseille, we have Interaction data centers that made some noise recently because there is a fifth data center from this company that will be built, and there are local oppositions. And if we take 3 of the 5 data centers they have there, we combine them. They are pretty big data centers already. It's about the size of this one. So the size in terms of land use is pretty huge. The power installed too, it's about 250 megawatts. of power required so far, because it might be extended. And what we can see, so first element that you will see on many data centers, looking at it from satellite images, it's the cooling, because most of the time you have many of those kind of looks like Legos, if you have the reference. So most of the time it's for cooling. So here it's probably air cooling on the outside, like dry coolers, it's called. But what is really interesting regarding electricity production is this. So those are electricity generators based on methane gas. So methane, CH4, one of the most global warming gases, much more than CO2. And you have like 30 generators like this. So some are here, some are here as well. And those generators, we know, thanks to the Guardian, that they have been installed, powered, and running before XAI had the permits to do it. So there is kind of a rush from generic data centers operators to have the power quickly, abstracting themselves from the constraints on the grid, so from the delays that having access to the needed power might take. They want the power now, and they are ready to generate this power locally. And we are not talking about renewables, we are talking about gas turbines. So this is a first example of it. There is also a small, an element that's interesting is this one. So it's, those are batteries built from Tesla. So those are Tesla Megapacks. Those are huge batteries compared to the one you might find in a typical data center. That's why they are outside. It's taking a lot of place. It's all over the place. And why is that? First is for, let's say, power safety, of course, but it's also because at that scale of power installed, you don't have the same risk regarding the electricity grid. If you have a data center with a few megawatts or 10 or a few dozens of megawatts, it's almost nothing for the grid if the data center's power is cut or comes back online in a few seconds. It's okay. Those are not power ranges where it might create problems on the electricity grid. When you talk about hundreds of megawatts, and for some bigger data center, potentially a gigawatt, then you might have issues, and those batteries can help to mitigate this problem, so you don't create perturbations on the network. And so quickly, just to give you a last example of this local electricity production, we look at data centers from OpenAI this time. So the first site, which is called Stargate 1. So just for the recall, so you have an order of magnitude. This site, once it will be finished and operational fully, will ask for 4.5 gigawatt of power. So it's really, really huge. In terms of land use occupation of the buildings, it's more than 400,000 square meters occupied. So far, all the buildings are not constructed. You see there are 2 of them who are operational here, 2 of them who are almost operational, 2 of them the construction just started, and 2 other places where the building are not built yet. And what's really interesting regarding local electricity production is this. So here you can see it's once again, gas-based generators. This time it's not methane, it's let's say traditional gas. And you can see with the big chimneys like that, it's really typical of that kind of generators. So we see that, and this is a typical example, we are talking about gigawatts of power. So of course, even in the US, with big budgets for electricity, it's not possible to give access to gigawatts of power just in a few months, like the Gen AI actors would like. So they are going back to local electricity production. So maybe I will take just, if there are questions, I will take some now before I go to the workshop and the methodology. So Gael, could it be fake data due to US national security rules? What was, Gael, what was the data you are talking about, just to be sure?
Yeah, you say the data center was deleted or erased, but it can also be that now some data centers locations are forbidden to be displayed publicly.
Yeah, we thought about that. In this particular case, it seems that it's not the case, because I just showed you one map tool for this location, but if you compare with others, we see coherent data, and we see that some other items on the construction site have moved and changed. So it seems like those are actual 2025 images. We might be mistaken on this one, but most of the time when there is a data center site that either governments or companies don't want you to see, it's just blurred. So all the whole zone is blurred and you can't have the actual image. So here it's very strange because we do have images that look like not fabricated image, even if we can be mistaken. So yeah, that could be a track. It's just that on this one it seems not the case, so it seems really happening. But let's see in the future, maybe we'll have other information.
Okay, thanks.
So now regarding the methodology we use to track data centers in France, and the first results that you will see in the report, but for some results here, so you have a concrete example of the results the workshop might generate. So the methodology is pretty simple actually, and for real, everybody can do it. There is no technical lock-in or hard constraints that might prevent someone willing to do it, to actually gather data. That's why I really believe in this collaborative aspect of this practice. So to describe it simply, so first you get an intel on there is a data center at this place. So it could come from either direct discussion with someone who is interested in the topics. It could come from press articles. It could come from existing private databases where you already have data on many data centers, but just not all of them. It could come from any intel actually you get. Now you want first to assess that it looks like a data center. That would be first good step. So that's why the satellite images are good, because you will see patterns. So you saw previously on the example I showed you that there are some items that we recognize. And here on this one, it's what I described. It looks like Legos once again. So those are for cooling. And in almost every data center you will find those typical patterns regarding cooling, and so you can have an insight on, oh, it might be a data center actually. If at this point you have enough data to say it could be a data center, then you can get its dimensions, you can get the area it covers, the land use, at least of the building at its base. And then if you want to ensure that your intel is good, so one thing we did for France, but we could do elsewhere as well, is crossing those satellite data with what we call cadastre in France, but let's say the public registry on land plots sold to a company or an individual, which company or individual is owning the land, which company or individual is occupying the land, has a building there, is occupying the building or not. So this kind of registry is very interesting for that. And in the example I'm showing to you, at least we can assess that we had an intel that this data center was from BNP Paribas. And then in the cadastre, we can assess that this land is owned by BNP Paribas. So it kind of confirms that at least we are not mistaken on the company operating it. And we can go further. And at this stage, we've just do two kinds of data sources. We can have the square feet or square meters land occupation, the same for the building. Then we can calculate the square feet or square meters of the floor area in the building. The same for the IT area in the building. With cadastre or similar registries, we have the building height. And at this stage, we might have other information, but sometimes we don't. We just have this. So what about installed power? What about data center operations start date? It's very interesting to know when it started operating for many reasons. Or other information that you might want to get, like the PUE or other indicators. So first, very simple, but actually very effective. There is, in many cases, there are documentation regarding this data center. So either it's a PDF somewhere on the operator website, or it's on the website directly. Even if it's not a co-location data center, so a data center whose business model is to rent space and power to clients, even private data centers, sometimes you have the information on the website of the operator, even if we might believe it's not the case. And if you don't have, for example, power, which is good is that at the point where you have a database that's pretty filled of data already, you can categorize the data centers you have, and then you get ratio, and you get ratio of power per square meter or power per square feet or the opposite. And so you can infer the power based on the surface or the surface based on the power. So that's what we did for France. And lastly, for like operation start date and other informations, especially those that are, you want to know what they told about the data center in the past. The press articles are very good because most of the time, even if the company doesn't communicate, it's almost every time like a local pride to have a new data center being installed. So you will almost always find a press article from a local journal, could be from the town, from the department, from the region, let's say, scale. But you will find a journal that will talk about it and give you at least the operation start date. So yeah, so that was just to illustrate this methodology we used for the French study, and now some results so that you see what could be generated from that kind of methodology. So we gathered information regarding 352 data centers, active data center in France. It's a bit more, it's like something a bit more than 400 if we count the closed ones and some of the projects. But the projects are very hard to separate, let's say, the marketing and the fame from the truth. But yeah, so far on the active data centers, we have accounted for 2.4 gigawatt of installed power. So you see that France compared to the US is still really tiny. Because as I said before, if you just take Stargate 1 from OpenAI, it's like at its term, it could become 4.5 gigawatt. So it would be like almost twice French installed power so far. And regarding the surface, so we accounted for 2.44 million square meters of floor area. So it would be 26 million square feet and 1.12 million square meter of IT area in the data centers. That would be 12 million square feet. And we started to account for the projected data centers, for the future ones, including those that have been announced in the AI Summit. And so far we have something like 2.5 gigawatts of power projected. So you will find much more than that in the ADEME exec summary and in the report. Just like last element, the classification of data centers for our database. So it's on the right. So the big blue part and the red part on the bottom are actually colocation. So wholesale and retail, those are just two categories of colocation. So wholesale are like colocation data center that have more than 10 megawatt of power. Retail are colocation with less than 10 megawatt of power. Private data centers are the ones that are operated for the usage of one company only, and it's not the business of the data center to sell to multiple companies. The light blue one is HPC, so it's high performance calculation, so very special data centers, and orange one is the public data centers. So yeah, so now it's 25. So yeah, now I would like to focus on the workshop, if you are okay with that. So I just have a look. What is talk of data? Yeah, yeah. A few reasons to hide the data, but it's not that hidden. That's the point of this workshop. So what I propose to you is I will share to you just a collaborative document where there is a data model. So it just basically fields of information to find regarding a data center. That it's just a suggestion. Like you can add any other information, relevant information. So if you find something else that you think is interesting, don't hesitate to note it as well. And to help you fill this data model. So the idea is you will connect on the document. If you want to, if you have an idea, you heard or you read about a data center, you want to have information about it, anywhere in the world, you copy this data model and you say, okay, data center one from company A, and then you can start to fill. Anyone connected to the document can help you collect the data. So try to identify it, putting the right name at least, and people could jump on your part and add other element of information for this data center, or copy their own data model block and then start collecting data on another data center. So it's completely free. That's why I said it's pretty much an experiment to do it online, because in a physical place it's much more obvious, but let's try. And to help you, I will just show you a few, really not exhaustive, but just a few data sources you could use. So all the mapping tools like Google Maps, Yandex Maps, Living Atlas that I showed you before, OpenStreetMap, or any other, any private or less private database that already gives information on data centers, but some of the time, most of the time you will have just a few of those informations, or the specialized press or generic press. So it can come from anywhere. The idea is not to be perfect. The idea is to start gathering data and collaboratively see if we can refine it with time. And so I had the timing in mind, but I'm not sure we will hold it. But let's try. I will give you this link in the chat and invite you to start filling these documents. So don't hesitate to copy those blocks multiple times if you want to address several data centers. I don't have any audio feedback, so don't hesitate to take the mic if you want to ask questions or focus on the data center and synchronize with someone. So you can do it in the chat or with the mic, whatever you want. Let's see. Sorry, we are 5. That's good. Try. It would be good if you can put just your surname. You will have a small box that says, "Hey, put your name here," so we'll see who wrote on which data center, so we can maybe discuss with each other. And so it can come from anywhere. So if you don't have any idea about which data center I would like to get data from, it could be easy. Let's go to search engine and just say, okay, let's say, because it's the trend, Gen AI data center in Canada, for example. And let's see, okay, first example, tell us, opens Canada's first fully sovereign AI factory. So it could start from here. So where would be these data centers? I will have to look for information regarding the location, because it might be a project that's not, the construction might not have started now, might not be the easiest example, but that could start from as simple as this. If you have another idea, like you know about a data center from a company you work with, you can have a look and focus on this one, whatever. So I will just start talking for like 10 minutes, so you can try the process, try to get some data. I will answer the questions, of course, if you have some. And so see how it goes in 10 minutes, if you're okay.
I finding discrepancies between data sheets, company data sheets, and the website. The company data sheets was 250 megawatts for the one I put there, but the website, which I just found, proudly posts 500 megawatts. It's like, you know, they like showing off as much power as possible.
Are you talking about the data for
Yeah.
data centers? Okay. So you said 250 megawatts from the provider?
Well, from the data sheets, I haven't checked them yet. I'm trying to find it myself. That's what my AI found for me. But then I found the website, and the website says 500. So there's two.
Yeah. Okay.
Two completely different figures. The land size is roughly the same. One says 110, the other says 130. So it's kind of the same scale, but the electric power is very different. So presumably the data sheets are out of date and the website's up to date, I'd have thought.
Yeah. So what's interesting with this one is, I think part of the answer is that it's a campus. So it's like multiple data centers that are rented to different companies probably. And so accumulating the power to all of them at a given date might be complicated to find because they will announce the future capacity so that their customers think, okay, there is enough room for my project. But because some of them, you see, some of them are still being constructed, some are finished. It's very, very evolving because many data centers in one site. So that might explain also why you have differences. It's really this one is really it's a good example because it's typical of what you might find in small to medium data centers, a bit everywhere in France at least, and you will find those. I think you saw it, but just maybe for the other.
I'm thinking
you will find those.
A source of data that might be useful. I happen to know somebody who actually is just retiring from, but a company that designs data centers but doesn't run them. They might be more helpful. APL Data Centers is a French company. Do you know them? APL?
Yeah, I know some of them. I don't know everyone here, but some of them. If you know,
I did some work with them, and they did provide some data and stuff because as long as they can anonymize it, they were quite helpful when I was writing a white paper for Orange on sustainability. They gave me some real data.
Okay. If you know someone who might be keen to share some data about some of those data centers, that would be very interesting.
We have to find a story. I have to find the right story to tell them before making an intro. If it goes the wrong way, they'll just say, no, thank you very much. See you in another life.
No, it's okay. I understand. Yeah. To be clear, that's what I said. The idea here, and I don't hide it from even the people who have data. So we are building a digital common. So we might, when this database will be out, that would be a community project. We might have, for legal reasons, to hide some of the data or change it because we might be forced to. And that's okay. The idea is that in a statistical point of view, the database makes sense and gives people and potentially governments a decent understanding of where we are. That's the first, on my side at least. Maybe people from Data for Good will have other ambitions in addition to that, but I think it's the common one. So yeah, the idea is that the data is public, even if we should probably have to hide some of it for some sites. So that's sure that I understand if some providers don't want to share too much. Actually, that's why we try those workshops from time to time, is that we realize that there are many data available in accessible source. And so not direct, actually. You just need to cross the data sources.
Totally unrelated, but interesting. The big French AI company, it's not a data center, but they've just moving their headquarters literally to the building opposite my house. So I'm going to be next to 2,000 Mistral AI people. So maybe I'll meet someone. I'll ask them about their data centers.
So okay, the headquarters, yeah. The 1.0 gigawatt data center announced for Mistral AI is announced in Fuju. It's in, I don't know if it's in the 78 department or the 77. I have a doubt about that, but we'll have a look. Fuju. Yeah. But it's somewhere in the landscape.
From all the frontier AI companies, it does seem like Mistral, up to now at least, has been the one that's been the most transparent with the energy story. Of all the big companies, they're the only ones that actually went quite far trying to understand their environmental footprint.
Yeah, I kind of agree. Yeah, I think the thing is my take on this is that I'm still a bit disappointed about the perimeter we look at when we talk about those topics, because looking at the inference, the tokens, let's say the usage metrics, it hides the infrastructure behind it. It hides the big dynamics, both in terms of hardware, economics, and it's easy to just tailor the perimeter you are looking at to say, hey, one inference, it's not that much, even if it's more transparent than the other provider. What I think we would really learn a lot by switching the focus to the infrastructure in itself, not just per user or per inference metrics. But out there, it's okay, Leila. Thank you. Yeah, going for a map directly may be a bit hard. You might want to start a press article or something that will give you an insight. So, in Omega 1 data center in La Réunion, he wrote about it here. So let's have a look. I have a poor network today. Sorry about that. Yeah, interesting one. One with something that looks like solar panels on the roof. So that's a pretty nice coverage, if that's what I think it is. Most of the time they communicate a lot about the solar panels, but it's like a few solar panels on a big roof. Now the coverage is decent, I have to say. But I think you told me in La Réunion it's pretty common to have a real focus on this, which makes sense. Yeah, it's interesting. Okay, we have a. Thank you, Alexi. Great. I hope it will contribute to some ideas of yours. Don't hesitate to reach back afterwards if you want to continue the initiative in some way or another. Thank you, Leila. We still have Alain, Ben, Benjamin, Emmanuel, Eric, Jesper, Stéphane. So yeah, for the few minutes we have, does someone want to have a look at a data center, ask question, or maybe Emmanuel, I saw that you tried on Google's data center in Saint-Ghislain. If you want to take the mic or write something about it, don't hesitate. So in Belgium, yeah.
So, as an expert, how would you then go and dig further into that one? What would be the next step to try and say get the power or something for if we look at the Saint-Ghislain from Google?
Saint-Ghislain?
Yeah.
Yeah.
So you type into Google. Go to Google search.
That sometimes it's one of the ways. As I said, when it's not communicated directly in some way or another, you start from. So what I would do is this. I would go to the satellite view. It's interesting because it's the solar panel farms here and the data center. It should be there. Yeah, looks like it. Looks like it. Those big opening, most of the time it's evaporative cooling. But we might have to check. But yeah, it looks like it. So if I confirm that's the right site, what I would do is that I would, so either I get it from the cadastre or another registry, or I get the dimensions of the data center. So you take his length, his width, you get the area, and then you have the number of square meters or square feet. And because now we already have that's what you don't have for the workshop, so that's harder. But in the end, that's the idea. The database will be public, so you can just have a look at the data centers of the same category, and then you take the ratio for that kind of data center of power per square feet meter or power per square feet or square meter, and then you infer the power from the surface if you don't have it anywhere. And so that's a yeah. Go ahead.
For example, so what you do with, I just pasted there, this is public relations from Google around that.
Mm-hmm.
You take their numbers at face value. I mean, it's pure PR. If you click on that link,
yeah,
like
okay.
the Saint-Ghislain one, they're saying we're so good, we put all these solar panels up and stuff.
Yeah.
And there's numbers there. Would you take those numbers at face value? They're from 2016, so they're like 7 years old.
Yeah. No, if you have nothing, like every data can be interesting. So that's the point. You know, as you identified it, you know that coming from that kind of source, it's probably not accurate and it's probably not reliable. But it's interesting to get it, store it in the database or in your file, and then do the exercise I proposed you so I will do it quickly with a ratio that I have in my mind. That's probably not the best one, but it's okay. So it was like something like where is my
Okay, so I just stored it in the document.
yeah, store it.
Google's
Yeah,
own
just I will need to. Okay, so it was like 383 square meter per. I said, whoa, my network. It was I think it was 63 just for the exercise. So it's like 24,000 square meter, and I think
they actually have a number in there, 2.8 megawatts.
Yeah, but it's 2.8 megawatts of solar panels, I guess, if I read correctly. So that's the solar farm that we saw just before. So, and it's a big solar farm, but it's I think the ratio is something like 400. I will open the database quickly. And we'll get a ratio so we can see if that's possible or if it's not that's possible. So no. Yeah, kilowatt per SDP. Okay. So we are more in the hyperscaler side. 154. Okay. Well, hyperscaler, maybe it's not the best category, but still, it would be something like 38 megawatt at least of power on this one. So you see that, so it's just we should refine that, but to have an order of magnitude, at least 38 megawatts needed for this kind of data center. And here they announced 2.8 megawatts of solar plants. So that's interesting because if it's the same, the only number they gave, that's a typical strategy of I show a number that people will stick to their mind and they will get that it's the full value.
So if your number is roughly right, what you're saying is that the solar that they put there in bright sunlight will give about 8% of the power they need.
Yeah. That's the idea. Uh, 2.8 megawatts. Yeah. Oh, no, I did it wrong. What did I say? 38. Yeah. That's exactly that's the idea. Between 7 and 8% of the power, and that's also it's just about power. We are not talking about energy, because as you know, if we talked about energy, probably it's much less, because it's just power in best conditions. Let's say the curve of consumption of a data center is not exactly fitted to the usual curve of production from solar panels. So you would not use those solar panels at their best all of the time. So in terms of energy, it's probably much less. I had an example of it. It's like I think it's MRS 5 from Interaction in Marseille, the one that created so much tension in the file they sent to ask for the project. They talked about solar panels, and so I got the surface covered by solar panels. I did a rough calculation between what should consume in a year this data center and what could produce in best conditions those data centers, those solar panels. And it was something like 0.14% of the energy consumption in a year, probably. Okay. So, but that's the kind of order of magnitude that you find almost everywhere. Maybe Google is a bit better because they actually do real investments in this topic, but still it shouldn't cover most of the consumption.
But tell me something as a specialist in this area. When you did your presentation, you kind of added the more power hungry, more powerful servers we're putting in for AI. And it, as if we're kind of in some kind of continuum from the data centers we started building 20 years ago, and they're slowly getting more powerful, more powerful, more powerful. And it felt like a continuity. And the feeling I get, and this is, I don't have any science behind it, it's just a gut feeling, is that we're entering a new age, that the way we look at data centers and think about them in the age of AI, the data centers dedicated to AI, they are different beasts, that we need to start with a new way of looking at them and analyzing them. That's my guts telling me that if we just continue as we were before, the way we measure things, the way we understand things, it kind of breaks. We designed, and people like you have been thinking about this for a long time. I haven't, but I've been thinking about other things for a long time. And I know that when you get really specialized, you sometimes miss the fact that we're in a new world and we need different things. How do you react to that? These new, the data centers being built in 2025 and 2026, the new ones just for AI. Should we just continue the same way, or do we need to change the tools and the way we look at them?
We should partly change the tools. There are some tools that still work. So I showed some of them discussing just now. So it's still valuable. It still gives you interesting informations, but you are right. It's related to the beginning of the presentation. It's about what is really typical of Gen AI data centers and different from classical data centers. It's about, for example, local electricity production that will, for example, you see, if you want to compute the greenhouse gas emissions associated to a data center, before you could just focus on the location-based greenhouse gas emissions from the grid. Now it's probably not enough, because you will have to account for this local electricity production that's not published anywhere. I mean, the how you should compute. So you can do the computation if you know what kind of generators and comburant it is, but you have to do this exercise. What would change? What would change are the ratio, because as I said, if you have a database with enough data, you can use ratio to compute the information you lack on new data centers. But if those data centers are several orders of magnitude bigger than the previous one, then your ratio are outdated.
And maybe there's another angle, Benoit, is that when we're on CPU and storage-based data centers, the kind of shelf life of the hardware, was at least 5 years, and sometimes you had 8, 9-year-old equipment that can still do useful things. In the new era of GPUs, NVIDIA just said they're moving their main new versions from once every 2 years to once every year. Doesn't that mean that a data center sort of turnover of hardware, and therefore the embedded carbon story, is going to change? Because presumably NVIDIA wants to continue dominating the world. They're going to want to, they've sold gazillions of chips to people in, say, 2022 or something. They're already trying to sell them upgrades, I imagine. And the upgrade cycle is it going to shorten? Presumably, is that in your modeling somehow the average lifespan of the actual hardware running the inside?
Yeah, we have hypothesis. Yeah, you're absolutely right. There is this trend also of shortening life cycle. I think to be honest, the prospective model that we did for the study, it was more Eric's topic, so I don't know it as much as he does. but I do think there are hypotheses in it that take this into account, the changing lifetime of the hardware. So I think when the report will be released, will be much more exhaustive than what I'm telling. But yeah, you are absolutely right. It's one of the trends to take into account. I answered first on a very database, data center centric view, but if you look at what's inside for your evaluation, you have to change the hypothesis as well. I fully agree. Yeah, sorry, Emmanuel, I didn't jump on your sentence. We are in the end. I won't take too much of your time, but if you can find the power, yeah, it would be. At least I saw that you found the surface. So I think it's you who wrote this. And so because you have the surface, so you have the surface of the land, what would be good is to get the surface at least of the base of the building. But once you have that, which is possible with the images we saw, you can, I know today it's not public, but when it will be, you will be able to translate surface in power. So that would be a way to do it, as I try to illustrate. And yeah, it was this one.
Okay, I have to go too now. So thank you very much.
Yeah,
it was
it's
a
okay.
really interesting and fascinating project. And when you talk about crowdsourcing, I'd have thought there might be an opening to a much wider audience than us people that kind of work on these subjects in the daytime. And, you know, I could well imagine thousands of people in France being interested in such a project. Do you have plans to make it public to the
public? Yeah, absolutely. It's that's why we are discussing with Data for Good and with the Shift project. We are discussing about how to make it happen, but that's the idea, to make it available to everyone, to welcome everyone's contribution with a review process so that we ensure that the data are coherent and so on, but still something very open source like, with a database and a map, and everyone could propose new data or changes, and with time refine it to a database that makes more and more sense. So that's really the idea.
Okay, and just as closing, because I didn't understand in the beginning of your presentation, what is the context of this work? Is this academic work? Are you doing this on behalf of a company? Is it a citizens initiative?
As I said, the beginning was the study we are doing for ADEME. When I say we, it's Laurent, Eric, my colleagues from Hublot. So it was a professional project, but it's just that the data we generated, we thought right in the beginning, we thought, okay, it should be public data, at least those that we can make public. And so the idea was, let's make it a citizen-led project, structured by non-profits like Boavizta, Data for Good. So we don't know yet exactly the structure we want to make, but we know that there are at least some actors that should be involved.
Okay. We'll keep greening of streaming in your mind for when we need more people at the table. Thank you very much.
Right, I know that. Thank you.
I look forward to.
Thank you, Ben.
Bye.
Thank you, Emmanuel. Thank you, Stefan. Have a nice day.